All right, you mathematicians, let's do this part 2 video where we're going to solve something with a little bit more steps than what we have been doing. So I am needing to get the square root by itself, and since there are 2 of them, I'm just going to take the one closest to the equal sign and subtract it. It doesn't actually matter, you'll still get the same answer. Plus x plus 1 seems easier to deal with. So we are going to, so then I get 1 minus the square root of x plus 1. Now I've got my square root by itself on the left side, and I'm going to go ahead and square both sides. Okay, what I want you to make sure you see is if you look right here, that is a minus sign. That means this is a 1, 2 different terms, which is a binomial. So when we square both sides, we have to put it in a box because we have a 1 and minus this, and we can't combine them. So we have not seen anything like that before, but I think that we will be able to do it. So let's do this one together. So I know that this is a little bit different. So we're going to get 1 minus the square root of x plus 1 all together. And then we have a 1 minus the square root of x plus 1. So we end up with 1 times 1 is 1. 1 times the negative square root of x plus 1 is the negative square root of x plus 1. 1 times the negative square root of x plus 1 is square. Oops. Let's go back. Okay. So we have the square root of x plus 1. Now this part is a little bit weird, so I'm going to write it over here. So we have a negative square root of x plus 1 times a negative square root of x plus 1. A negative times a negative is always a positive. So we have square root of x plus 1 times the square root of x plus 1, which is going to be equal to square root of x plus 1 squared, right? So those undo each other, and we're just left with x plus 1. So the negative times the negative gives me a positive, and then that undoes it, so I'm just left with what's underneath the radical. Okay, so now we have to combine our like terms. So a negative square root x plus 1 plus a negative square root x plus 1 is going to be a negative 2 square root x plus 1. So now that I have that, these parentheses right here are just to show you that I took the whole thing underneath the radical right there. If I multiply by a 1, I get rid of the parentheses, so no worries there. All right, so now we're going to combine our like terms on this side. So I have a 1 here and a 1 here, which gives me a 2. And so I'm going to end up with, and then I want to make sure it's this whole thing, this negative 2 times the square root of x plus 1, I want to get it by itself. So I'm going to subtract, 1 plus 1 is 2, so I'm going to subtract 2 from this and from here. So minus 2. The 1 and the 1. That's where I'm getting it, because I'm getting 1 plus 1. And then I want to subtract this x. So I'm subtracting x, subtracting x. And I end up with this right here. So I end up with x plus 1 is equal to the negative square root of x plus 2. Now I want to get rid of that square root. So I'm going to square both sides. Again, make sure you see that this is a binomial and that you need to put it in a box. This we can use on one of our rules. Hold on, let me hit pause. I think my face is in the way. Okay, so we want to apply that exponent rule that of ab squared is equal to a squared b squared. So that's this step right here. So then we end up with, x squared plus 2x plus 1 is equal to 4 times x plus 1. And we got that because this squaring right here undoes that square root, and when we square negative 2, we get a positive 4. So we're left with a positive 4 times whatever was underneath. Now we need to distribute. So make sure you hit pause and get this in your notes, because I'm going to move to the next screen. All right, back to where we were. So we are going to distribute that 4, and we end up with x squared plus 2x plus 1 is equal to 4x plus 4. Now I need to get it, I have a quadratic, so I need it to get it to equal 0. So I'm going to subtract 4x from both sides and subtract 4. So I'm going to subtract 4x and minus 4. So then we end up with x squared minus 2x minus 3. Then we need to do box and diamond. We need to factor that out. Once we factor that, I get x minus 3 times x plus 1. Remember, we're going to use the zero product property, set each one equal to 0 and solve. I have x minus 3 is equal to 0, and x plus 1 is equal to 0. So I end up with x is equal to 3, and x is equal to negative 1. But I am not finished. I also need to make sure that I check my answers. This is huge, and this is crucial, and I need to put it back into the original equation. So I'm going to check 3 first. If you wanted to check negative 1 first, you could. So I'm going to plug 3 in everywhere and x was at in my original equation. And then I end up with the square root of 6 plus 3 plus the square root of 4 is equal to 1. Well, the square root of 9 plus the square root of 4 is equal to 1. 3 plus 2 is equal to 1. No, 5 does not equal 1. Not a solution. All right, now I'm going to try negative 1. All right, so then I get negative 2 plus 3, which is 1, plus, so the square root of 1 plus the square root of 0 is equal to 1. The square root of 1 does equal 1. 1 equals 1, true. So my only solution is that x is equal to negative 1. All right, so that is my solution set. All right, so our last one is doing examples where our indices, remember our index is this number right here, is greater than 1. Or I'm sorry, greater than 2. Sorry. Square root greater than 2, because we've only done square roots. All right, so what I'm going to do to isolate, well, I'm going to try the power rule, and I'm going to take it to the third power to undo those cubed roots. Oh, good, I can cube both sides. That undoes both of them. So this undoes this, which undoes this. Oops. Undoes that. So I end up with 2 linears. Okay, linear. So that means that the degree is 1 right here. So I want to get all my x's on one side and all my numbers on the other. And I end up with, well, if I do that, I would subtract 2x from this side. And I would add 2 to both sides. And that gives me 9 is equal to x. And now I just have to check it. So I get 2 times 9 plus 7, which is going to be 18 plus 7, and the cubed root of 9, so 27 minus 2. I end up with the cube root of 18 plus 7, cube root of 17 minus 2. I get the numbers underneath that. I get the cube root of 25 is equal to the cube root of 25. This is good enough for my answer. I don't need you to tell me what the cube root of 25 is. This is good enough. You can leave it just like this. And that is true. I've checked my answer, I've solved it, and I am done. All right, so that was my last example for today. I hope you all have a great weekend. Happy Friday. And if you have any questions, I did go through this rather quickly. If you have any questions, let me know on Monday, and we will be reviewing, and the test is on Friday, March 5th. Have a great weekend. Bye, you mathematicians.